There are 4 stages of automation from that Paris Harmon paper that talks about different levels of automation. There's information acquisition, which is where you're drawing in data from your environment, information analysis, trying to form ideas about your environment based on that data, decision and action selection, so taking that information and developing what your next step would be, and selecting that action, and then implementing that action. So you can have the human doing these tasks, or a computer doing these tasks, the automation doing these tasks, or you can have a combination. So we'll go through the different levels as defined in that Paris Harmon paper. So there are 10 levels that are described, 1 through 10, 1 being the lowest level of automation and 10 being the highest level of automation. And here I have it described as a human is listed as an H in this matrix and automation is listed as an A. So level 1 is where human has complete control. There's no automation in all of those different stages. And then level 2 is where we start looking at, for information acquisition and analysis, involving the automation as the computer offers sets of decisions and actions based on that information acquisition and analysis. And level 3 is where we've got the computer narrowing down those decisions. So now they've fallen into that decision and action selection portion of that model. Level 4 is where it gets down to selecting or suggesting one alternative, not a range of alternatives. So information analysis and decision and action selection are completely autonomous. Now level 5 is when it executes with human approval. So level 5 through 10 is where you start getting into automation completing the action implementation. This level 5 still requires human approval, so the human is still involved in that implementation. Level 6 is restricting the time to automatic execution. So like if you've got a timer to make a decision, and if a human doesn't stop that decision, the computer will go through with that action. And so the human is still somewhat involved in that. And the human is always involved in information acquisition up until complete autonomy. So level 7 is when automation executes that action and then informs the human. So there's complete autonomy in these 3 levels, or these 3 stages. Level 8 is only when the human is asked, or only when the automation is asked, will it inform the human of the decision. And level 9 is only if the computer decides to inform the human, whereas level 10 is just complete autonomy. So those are the 10 levels of automation and where they fall in the 4 stages of automation. So when we look at examples of levels of automation, we have Excel sheets, and those fall under level 2, where you've got where you've got a computer that will take in information that you've gathered, and then it creates a list of outcomes. It's a decision aid, so it offers that set of decisions. GPS navigation, that's an example of level 4 automation, where it's suggesting one alternative. There are some that are in level 3 and level 4 where it'll offer you multiple routes, but it's just trying to help you guys think about things in your everyday life that you experience that are in these levels. So I would say navigation is in level 4. Then we have plain autopilot, like setting a course and navigating that. I think that would be on level 7 or 8, where you're setting it to an autopilot, but it makes corrections as needed and really only informs the human if asked, or after an action is completed. And then you get into level 9 and 10. The only example I can really think of is HAL 9000 from 2001: A Space Odyssey, if you've seen that movie. where this automation system basically just does what it thinks it's best, and doesn't really inform the humans, and it causes a lot of trouble. But those are some examples of the different levels of automation and things that we see around the world. All right, so in 1951, Paul Fitts created this list that we still use today, and that list explains what functions, what tasks should be assigned to humans or computers, which we still use today as a way to allocate functions in a process, to try and figure out whether or not we should automate a system or leave it at a human level and put more emphasis on designing for a human or developing that automation. So the things that humans are better at in this list are detecting small amounts of visual or chemical signals over a range, or perceiving patterns, detecting signals with high levels of background noise. Humans are really good at improvising and storing information for long periods of time, and being able to sort through that information, as well as reasoning and exercising judgment. Humans are really good at that side of things, whereas automation is really good at monitoring processes, and detecting signals, ignoring factors. A lot of times as humans we let biases affect our judgment of factors, and automation computers are really good at that. Responding quickly and applying precise force, repeating a procedure in exactly the same way. Like I said, perfect to a fault sometimes. So that's why humans are better at flexible procedures. Automation is also really good at storing a large amount of data, but they erase it after a certain amount of time, whereas humans are really good at picking out information that's been stored for a long amount of time. Reasoning deductively instead of inductively, and then performing many complex operations at once. Automation is really good at multitasking, whereas sometimes humans are not. So this is a list that many people use to determine whether or not a person should be designed for in this situation, or if automation should help the human or supplement the human or replace the human. So the next section we'll talk about is how, when we don't want to use automation for a task, how do we make that task better for the human?